So here's the first one. It's a little interesting. Log base 9. Oops, not 9. Looks a lot like a G. There. Log base 9 of log base 2 of x equals 1/2. So here is one example of an equation that can have logs of different bases. So you can't add or subtract logs with different bases together, but you can take a log with one base of a log of another base. So yeah, that's kind of interesting. So let's try and solve this. So if I was going to solve this, I would kind of ignore this in the middle of the thing. I would just say, okay, look, I've got log base 9 of something. I know that 9 equal to 1/2. So I know that 9 to the 1/2 power should equals whatever is inside the argument there. So I can say that 9 to the 1/2 is equal to all this, which is log base 2 of x. That's how I would start this problem. And then 9 to the 1/2 is just the square root of 9, which is 3. Also, good morning to respond. Basics is good morning. Good morning to you as well. So 9 to the 1/2 is 3 equal to log base 2 of x. And then we can do the same kind of thing. We can rewrite this logarithmic equation as an exponential equation. The base is 2, the power is 3, it's equal to x. So x is equal to my favorite number, which is 8. And that does make sense. If we plug back in 8, log base 2 of 8 is 3, because 2 to the 3rd equals 8. And then log base 9 of 3 is 1/2, because 9 to the 1/2 power equals 3. Cool. Also, in case you care, you don't have to care, but my favorite number is 8 because I was born on the 8th month and the 8th day. My birthday is August 8th. I might have said that before. I might not have. Anyway, other equation on this page that we want to look at. Where'd you go? Oh, yeah. This is similar. So we did a problem like this last class too, but it's good to practice. Practice makes more perfect. So 10 to the 2x minus 3 equal to 4. So if I was doing this problem, I would definitely use log base 10 because I've got 10 to something, right? I know last class I talked about how you can use really any logarithmic base you want. It usually makes sense to use either something you have like 10 or 4 or natural log or log base 10 because those are kind of the standard base choices. So here I'm going to use log base 10. And I feel like there's really kind of two ways you can go here. One way, and kind of the usual way that people start doing this after they've done it for a while, is to just take the log base 10 of both sides. So log base 10 of 10 to the 2x minus 3 equals log base 10 of 4. Now I wrote the base even though I didn't have to, right? We could just write log of 10 to the 2x minus 3 equals log of 4. Now, I need some help. I need you guys to tell me, what do I get when I take log base 10 of 10 to the 2x minus 3?
Two x minus 3?
Exactly. And this is always going to be true when you have a log with a base that's of something that has the same base to a power, right? Because what you're really asking here is 10 raised to what power equals 10 to the 2x minus 3? Well, of course, it has to be 2x minus 3 because 10 to the 2x minus 3 equals 10 to the 2x minus 3. So you can either think of it that way and just say, oh yeah, this is 2x minus 3. But if you don't like that, and that's okay, you can also use the rule that says you can bring the power down in front and then write this as 2x minus 3 times log base 10 of 10 equal to log base 10 of 4. And then log base 10 of 10 is 1 because 10 to the first power equals 10. So right, we're asking 10 to what equals 10? Oh, 10 to the first equals 10. So this is just 1. So I get 2x minus 3 times 1 equals that. So 2x minus 3 equals, I'm going to write just log of 4 now. I'm writing the abbreviated version of log base 10, which is just log of 4. And I'm just going to solve for x. 2x equals 3 plus log of 4. And then divide everything by 2. X equals, you can either write 3 plus log of 4 all divided by 2, or you could write 3 halves plus log of 4 divided by 2. Either way would be fine. I probably would write it like this, yeah. Really blurry. Darn, that's terrible. I don't think I have anything stupid open. Let me, yeah. Why the blurry? Why? That is disappointing. Let me quit as many things as I can. I probably don't need any of that. Oh, I do need this open. Let me close this. I apologize for the blurriness. That is unfortunate. Let's see here. Nothing. Quit that. Quit you. Those aren't things that should be taking up a whole lot of processing power, but yeah, no office hours Monday because there's no class. Fair question, Mason. Yes, no office hours on Monday, no class on Monday, no anything on Monday. Is it less blurry now? Whether or not it's less blurry, we will carry out. Homework will not be due on Monday. It'll be there is an assignment that will be due on Tuesday. So if you look at the dates for the homeworks, F and G, right? F and G? Yeah, F and G. They are due on Tuesday, the 19th, I believe, of January. It's towards the right. I wonder what that's about. I mean, I know I have the board slightly angled. I guess I can unangle it. Better. Oh, hopefully it's better. I will say all the words, and if you have questions, please don't hesitate to ask them. Okay, so the next thing we're going to do with logarithms is actually we're going to use them. Really, we're going to use them to kind of figure out how to evaluate things. For example, so I should actually let me just share this. Let me share the screen with you guys first to show you what I'm going to be doing. So here's what's given. Specifically, oh, come on, don't be silly like that. I don't want you to do that. Sorry. So I want you guys to focus on this part right here. I'm given that log of 2 is approximately 0.3, log of 3 is approximately 0.48, log of 7 is approximately 0.3. I guess I can write them down, right? It's not terrible to write down. So we know that log of 2, and that's log base 10, is approximately 0.30. Log of 3 is approximately, what have we got here? 0.48. I guess I write the 0 first. I often write my decimals without a 0 in front of them. That's fine. And log of 7 is approximately 0.85. And then we also have some natural log approximations. Natural log of 2 is approximately 0.69. Where'd you go? Sorry. Natural log of 3 is approximately 1.10. Natural log of 5 is approximately 1.61. And finally, natural log of 7 is approximately 1.95. So using just these given values, we're then going to try and approximate some other things. And so the point of this is that we're going to try and use the rules of logarithms. So for example, I want to approximate the log of 21. And so really my job here is to identify how I can write 21 as either a product or quotient of the numbers I have here. Specifically, since it's log base 10, I've only got 2, 3, and 7 to work with. So I can write 21 as 3 times 7. So I'm going to write this as the log of 3 times 7. And then I can break that apart, right? Log of a product is equal to log of the first thing plus log of the second thing. And then we know that log of 3 is approximately 0.4. So at this point, we should use the squiggly equal sign, the approximation sign, and say this is approximately equal to 0.48 plus 0.85. And then we can add those together. And I think we get 1.3, let's see, 1.33, I think. That should be right. Yeah, 1.33. So the log of 21 is approximately 1.33. That's all I'm asking you to do. Let's do a few more. So let's look at this one. Let's do the natural log of 10. Well, usually, not always, but a lot of the times we're thinking about what multiplies to 10. Well, 2 times 5. So I can write this as the natural log of 2 times 5, which is the natural log of 2 plus the natural log of 5. And that's approximately equal to the natural log of 2, which is 0.69, plus the natural log of 5, which is 1.61. And then adding those together, 1.61 plus 0.69 is going to be 2.30. You don't need the 0 at the end there, but it doesn't hurt to put it on there. This is not a chemistry class. We're not worried about like significant digits or anything like that. Use the decimals you've got. All right, let's do a few more. So they get a little trickier once people start writing them, like once you start having some decimal numbers, some fractional numbers. So let's say we have the natural log of, what do I got here? 0.6, 0.6. So you'll notice that there's no decimals on my list. I mean, there's no natural log of decimal anything. And you might kind of think, well, 0.6 is kind of like 2 times 3. Here's the thing. If you've got a decimal, it's really going to be in your best interest to write it as a fraction. So I'm going to write this as the natural log of 6 over 10. And at this point, you could write it as the natural log of 6 minus the natural log of 10. However, it's going to be less work if we reduce this fraction first. So I really want to write this as the natural log of 3 divided by 5. And then I can say that's approximately the natural log of 3. It's not approximately, it is actually equal to the natural log of 3 minus the natural log of 5. And then that's approximately equal to the natural log of 3, which is 1.10. Minus the natural log of 5, which is 1.61, approximately. So this is going to end up being a negative number. It's about negative 0.51. And a natural log or any logarithm can equal a negative number. You can't take a logarithm of a negative, but if you take a logarithm of a number that's less than 1, it will end up equaling a negative number. Let's look at a couple more examples. Let's do the natural log of 2/7. Well, that seems pretty straightforward. I wrote natural log, I meant to write log log. Sorry, I was going to do log base 10. So log of 2/7, that's going to be log of 2 minus log of 7. And then log of 2 is approximately, I don't remember, log of 2 is approximately 0.30. And log of 7 is approximately 0.85. So then when we subtract these, we get 0.3 minus 0.85, which is negative 0.55. I think I see a question there. Let me see. How do you calculate the value of logs when they multiply by something? I guess I'm not sure what you mean precisely, Jesus, but here's my guess. I'm guessing you mean like, what if we have maybe something like for the natural log of 24? Is that kind of what you mean?
It was more like, how do you know that log of 2 is equivalent to 0.3?
Oh, well, so that's the given information.
Okay.
So if you look again, if you look at the right, so let me show you, right? So on your homework, on this next homework assignment, you're going to be given some values like this. You're going to be told that log of 2 is approximately 0.3 and log of 3 is approximately 0.4 and so on and so on and so on. So that's how we're getting those.
Okay. Thank you.
They're totally just given to us. I feel like there was one other thing I had here. There's usually there's one problem I know what it is, yeah. No? Yeah, I don't know. Anyway, we could do this one though. So this is 4 times the natural log of, so 24 is 8 times 3. And I wrote it this way on purpose because, so you could certainly write it as 2 times 2 times 2 times 3. Right? In fact, let me show you that. So you can write this as 4 times the natural log of 2 times 2 times 2 times 3. And then you could totally break this up as 4 times the natural log of 2 plus the natural log of 2 plus the natural log of 2 plus the natural log of 3. That's one way you could do this. And then it would be approximately 4 times natural log of 2, which is 0.69, 3 times. And then the natural log of 3 is about 1.10. And again, that's given to us. And then this would be whatever is equal to, right? It would be, I don't know, 0.69 plus 0.69 plus 0.69 is 2.07. So you've got 4 times 2.07 plus 1.10, which is 4 times 3.17, which is going to be 12.68. But there is a way we could do this with a little bit less work. And I just want to point that out. If instead, at this point right here, we thought of it like this, 4 times natural log of 8 plus natural log of 3. We can use the fact that 8 is 2 to the 3rd power. So we can say that this is 4 times natural log of 2 cubed plus natural log of 3. And that's equal to 4 times, the 3 can come down in front, 3 times natural log of 2 plus natural log of 3. And then we can say that's approximately 4 times 3 times natural log of 2, which is 0.69, plus natural log of 3, which is 1.10. It's not like a ton less work, but it is a little bit less work to think of it this way. So there are, as usual, there are lots of ways you can go. Sorry, I know my head's in the way. One more of these, and then we will switch gears and talk about simple interest. So again, your job is to make the thing that you're taking the logarithm of look like a product or a fraction with the numbers we've got. So let's look at this one, the natural log of the cube root of 4/15. I'll remind you, right, that for the natural log, the numbers that we have are 2, 3, 5, and 7. So we're trying to make this look like something with only 2s, 3s, 5s, and 7s. So first, I would rewrite this as the natural log of 4/15 to the 1/3 power. And before I can break it up with subtraction, I have to bring that power down in front. So I'm going to write this as 1/3 times the natural log of 4/15. And then that's going to equal 1/3 times the natural log of 4/15 is the natural log of 4 minus the natural log of 15. Natural log of 4, you can either think of it as the natural log of 2 squared or the natural log of 2 times 2. Either way is fine. So right, this is 1/3 natural log of 2 squared minus, what can I do with the natural log of 15? I can write it as the natural log of what 2 numbers multiplied 15? Now I want to be very, very specific here. The way I've written this, there's actually a little mistake. And the mistake is that, so if I did this minus this, well, I'm doing natural log of 4 minus all of natural log of 15. Well, this here is all of natural log of 15. So it should still be natural log of 4 minus all of this. So what happens is you have to distribute this minus sign to each of those terms. This ends up being 1/3 times, this 2 comes down in front. So we've got 2 natural log of 2 minus natural log of 3 minus natural log of 5. And then finally, we can do the approximation. This is approximately 1/3 times 2 times 0.69 minus 1.10 minus, is it 1.61? It is 1.61. So I end up with 1/3 times 2 times 0.69 is 1.38. And negative 1.10 minus 1.61 is negative 2.71. Right, when you have a negative number minus a number, it gets more negative. And then 1.38 minus 2.71 is going to be, let's see, so what I'm really doing is 2.71 minus 1.38 and then making it negative. So let's see, 2.71 minus 1.3 is going to be 1.33. I think. Yeah, that seems right. I mean, it's written in my notes here. And I would probably leave it like that. Yeah. All right. Let me erase the board on the back side. Hopefully things are not too blurry anymore. Do one thing here. I've got this carpet under my board, but I would like to still be under my board so the black dust doesn't get everywhere. Let me move this here. Oops. Okay. Fun times. Exciting times moving boards. Okay. Yeah, sure. That's fine. If enough. Okay. So let's go ahead and. Oh, good. I'm glad it looks better. Yeah. The problem with putting the board so close to the computer is that there's not a lot of room for me. I mean, there's enough room for me standing. But there's not really enough room for my chair, which is fine. It's fine. So let's go ahead and look at some simple interest. So when people say simple interest, that they're saying simple interest as opposed to compound interest. Which isn't really a thing. Like nobody really earns simple interest on something. Usually you're going to earn compound interest, but simple interest just means you're only earning interest on the amount you invested, and any interest you earn doesn't get like reinvested. Maybe like, I guess you could imagine like all the interest you're earning gets taken out and put somewhere else. So simple interest, you invest some money, usually called the principal. A percentage, the interest of the principal is added to the principal, making your initial investment grow. So I feel like it would be more sensible to just give you the formula right off the bat. Yeah, so here's the simple annual interest formula. And the formula is the following. The amount of money, I usually like to write the amount of money as a function of time, although you don't have to write it that way, is equal to the principal times 1 plus, I was going to write the other formula, I'm not doing the other formula yet, 1 plus r to the tth power, where, again, t is the number of years the money has been invested for. R is the interest rate as a decimal. So if they say the interest rate is 5%, we're going to write the R equals 0.05. If the interest rate was 23%, the R would be 0.23, etc. P is the principal, which I never feel like I spell correctly. It's all right. It's the amount you're starting off with. It's your initial investment. And then A of T, this is the amount of money you have at time T. Amount of money at time T. So that's our formula. for example, do I have enough room here? Yeah, I probably have enough room. Let's say we invest $1,000 and it earns 5% simple interest every year. See, this is, yeah, sure, okay. I might have misspoke earlier. I guess it's just called simple interest because it's not compounding multiple times per year, but it still is going to compound on itself. So I apologize for kind of saying the wrong thing earlier. Simple interest still does compound if you invest it for more than 1 year. So how much money are we going to have after some number of years? Well, let's take a look and see. T is the number of years. A of T is the amount of money. So after 1 year, I feel like I need a little bit more room here. So I'm going to move myself from here. So after 1 year, I'm going to have the initial $1,000 I had plus the 5% interest I earned. So 5% of the $1,000 is 0.05 times 1,000, which is $50. So that's going to be 1,000 plus $50. I'm going to stop writing the dollar signs because they're getting in the way. 1,050. So after 1 year, I have $1,050. After 2 years, here's what's going to happen. So this is where the kind of the idea of compounding starts to get into it. So here's what's going to happen. At the beginning of year 1, I now have $1,050. And I'm going to leave. Don't you need to add 1 to the interest rate? Well, so you're not wrong on Ace. But so I actually have done that. It's just not super evident. So in fact, let me actually show you. So here, so I didn't really use the formula, but if you look at this, I can factor out the 1,000. And if I factor out the $1,000, I'm left with a 1 there and a 0.05 right here. So that actually would be the formula, right? My principal, $1,000 times 1 plus my interest rate as a decimal to the first power, since we only did it for 1 year. So let's look at what happens if we do it for 2. Yeah, but you're right. There is a 1 there for sure. So if we did it for 2 years, so again, what's happening here is we're starting off with $1,050 at the beginning of year 2. And then at the end of year 2, we're going to have earned 5% interest on this amount that we had in the bank. So we're going to get 0.05 times 1,050. Well, look, the same sort of thing is going to happen. I can factor out the 1,050. I'm left with a 1 here and a 0.05 here. So I end up with 1,050 times 1.05. But remember, 1,050 was really 1,000 times 1.05. So this is equal to 1,000 times 1.05 times 1.05, which is really 1,000 times 1.05 squared. And you could keep doing this if you wanted to. I don't really want to, but I want to point out, right? So this is 1,000 times 1.05, and when T is 2, the amount's going to be $1,000 times 1.05 squared. And then if you did this again, right? So if you then say, okay, I started with this much, I'm going to have 5% more added on to that. Then I'm going to have this plus 5% of this is going to be 1,000 times 1.05 cubed. So that's kind of just to show you a little bit where this formula is actually coming from. It really is mathematically correct to say, oh yeah, every year I let the interest compound, I'm just going to multiply by another 1 plus whatever the interest rate is. Okay, so let's look at a couple of these. So what I will say about this is most of these problems is a lot of it's just throwing stuff into the formula and then finding the answer. And you'll probably want to use a calculator for most of these questions. They're usually computationally difficult enough that you're going to want to use a calculator. And that is perfectly fine. On an exam, if I ask you to do a question, I don't know. I haven't decided how I feel about calculators for tests yet. Usually in the past, we've kind of been like, no, but I don't know, we'll see. I probably say yes because, like, I don't know. I couldn't stop you if you wanted to, right? I'm not gonna. It's not gonna be a proctored test. I'm not gonna be like watching you use the calculator or not. So I think it's kind of silly to say don't use the calculator if I'm not actually watching anybody not use a calculator. So probably be totally open. Fine. All right, let's do these problems. Anyway, so Maria opens a savings account. I'm going to change the numbers a little. So I'm going to change the numbers in this problem just to kind of give you extra examples. You can totally look at the examples in the notes. I'm going to use different numbers just so you can see different numbers. So Maria opens an account that pays, let's say she pays 3% interest per year. So you could say 3% interest annually. You can say compounded yearly. Right? There's lots of different ways to say kind of the same thing. And she invests, she invests, let's say $2,000 in the account. The question is, well, question A, how much is in the account after 5 years? And this is kind of the point I was getting at, is that really all we have to do is just jam everything into the formula and get an answer. There's really not a lot more to this type of question. So if I plug everything, so again, the formula is the amount of money is the principal times 1 plus the interest rate to the tth power. So that's going to be the principal, which is $2,000, times 1 plus the interest rate, which is 0.03 to the tth power, and where t is 5. And then it's just pick up a calculator. So here's what I'm going to do. I'm going to do 1.03 to the 5th power. That's going to be approximately 1.159. And then I'm going to multiply that by 2,000. And then I'm going to get a number. It's 2,318.548149. I'm going to round it to the second decimal place because that makes dollars and cents. So this is approximately $2,318.50. I'm going to round up since it's 548. So I'm going to round it up to 55. But really, like, there's not a lot of thought going into this. We're just kind of saying, here's the formula. I know all the things. What's the thing I'm looking for? There are other questions we can ask them. So it does get a little bit more interesting if we ask the question like, how long will it take? Yeah, sure. Yeah, we can answer this over here. So let's answer the question. How long until she doubles her money? So to double your money, we're going to set the amount of money. So I should say, if the question is how long until she doubles her money, we know we're going to be solving for the time, right? Because the question is, how long does it take? What's the amount of time it takes? So if we know we're solving for time, that shouldn't have anything input for it, but everything else should. So I'm going to write down here. If I want to double the money, I know I started off with $2,000. And I want it to be doubled to $4,000. And then this here is going to be 1 plus 0.03 to the t power. And now my job is to solve for t, which is a little more work, right? We're not just plugging it into the formula and then getting an answer. We actually have to isolate t. Now, here's the thing about solving for a variable that's in an exponent. You're going to have to use a logarithm. But before we can use a logarithm, let's divide both sides by 2,000. So I divide both sides by 2,000. I end up getting 4,000 divided by 2,000, which is 2, equal to 2,000 divided by 2,000, just 1. So I get 1 times 1.03 to the t power. And now if I'm actually trying to get an answer that I can find on my calculator, I really don't want to, I don't want to say like, you could, but it'd be weird to write your answer as log base 1.03 of 2 equal to t. It's technically correct, right? This would not be wrong, but the thing about this is it's not really something you can evaluate with a calculator. At least I don't have a calculator that has a log based whatever you want button. Some calculators do, but mine doesn't. Instead, we're going to use the natural log. So I'm going to take the natural log of both sides. Take the natural log of 2 equal to the natural log of 1.03 to the t. And then the t can come down in front. And so if you're ever trying to solve for a variable that's in an exponent, usually the plan of attack is to take the log of both sides, usually the natural log. So then I've got the natural log of 2 equals t times the natural log of 1.03. And then I can divide both sides by the natural log of 1.03. So that t is equal to the natural log of 2 divided by the natural log of 1.03. And then if we use a calculator, we can actually calculate that. The natural log of 2 we know is about 0.69. I would still use a calculator. And then divide by the natural log of 1.03. The natural log of 1.03 is approximately 0.029. So the natural log of 2 divided by the natural log of 1.03 is approximately 23.45. So it's going to take a long time for, right? I mean, if you're getting 3% interest, it is going to take a long time for your money to double, but it's going to be approximately 23.45 years. Really? That's cool. Someone just told me that if you press the log button 3 times, it'll give you the option for any base. Oh, fancy. I didn't know that. I learned something new today. How cool. I will say, even though that's the case, I would still really encourage everybody to not solve it this way. Not that, again, not that it's wrong. It's just, if someone is seeing your work, they're going to expect an answer that looks like this. You should still get full credit for something that looks like this, but often people will write a question like, express your answer as logs with the natural base. So if you did this in an art class, I would be totally cool with that, but I want you to know that this is kind of the more standard way of writing an answer. But thank you for the information. That's super neat that you can actually do a log with any base by pressing the log button 3 times. So if you have a TI-36X Pro, you can press the log button 3 times and it will give you the option to put whatever you want for the base. How cool. I love learning new things about things that I should already know. I mean, not that I should have known that, but like, it's cool that I learned the thing today about my calculator that I didn't know. I'm happy to know. Pretty fun. Okay, so what else have I got here? A couple more questions. Yeah. So this one I think is funny, but whatever. So suppose Justin Bieber puts $5 million into a savings account. So here's what I want to actually point out with this question. As you read a word question like this, because it's definitely a word question, you want to write down what things are. So suppose Justin Bieber puts $5 million into a savings account. Oh, that's his principal. He's investing $5 million. And it's paying annual interest. So it's the usual. So paying annual interest means we've got the usual A equals P times 1 plus R to the T formula. And then after 2 years, so we know that the amount of money after 2 years, the amount is $5.5 million. $5,500,000. So what we know, what this really says here is that when T equals 2, A equals $5.5 million. Okay. And then the question is, what was the interest rate that he was earning on that money? So we have all the pieces to plug in except for R because we're trying to solve for R. So I'm going to plug in the amount is 5,500,000 equals 5 million times 1 plus R to the second power. And now we're going to try and solve for R. So so whenever you're solving anything like this, you're almost always dividing by this coefficient down here. So I'm going to have 5,500,000 divided by 5 million. We should definitely be able to make that a little bit nicer, but it's equal to 1 plus R squared. So I can definitely divide by a bunch of these 10s. And I can reduce that to 55 over 50 real easily. This is 55 over 50 equals 1 plus R squared. Let's take the square root of both sides. Also, I can reduce this even further to 11 over 10. Right? They both have a factor of 5. So I can say that the square root of 11 over 10 equals 1 plus R. And then R is equal to the square root of 11 over 10 minus 1. And then I would use a calculator and figure out what that was. The square root of 11 over 10 is 1.0488. So this is approximately equal to 1.0488 minus 1, which is approximately equal to 0.0488. And then the question says, yeah. So I would probably round that to 5. So my interest rate was approximately 5%, or you could say 4.88%. Right? Notice that to change it from a decimal back to a percentage, I moved the decimal over 2 places. So it was 4.88 or approximately 5. One other thing to be aware of is that this formula is also true for loans. Right? So a loan is just an investment by the person loaning the money. So interest also applies to loans.
For that problem, should we leave it as the square root of 11 over 10 minus 1, or should we?
I think it's probably worthwhile to use a calculator to get.
Okay. Thank you.
It's definitely, it's a balance, right? Like sometimes, and a lot of the time, obviously, like as you've seen me probably say, I usually want you to leave something as an exact answer. But when they're asking it, like the problem with this answer like this is it's not super meaningful. Like I don't know what that number really is. And so in this context, it does make sense to kind of round, to see what it is and then round it. On quizzes, do I want us to round up like that? I'll probably try and be very specific if I want you to round or not. Generally, you should always kind of default to not rounding and leaving it exact. But if there is something like this, I will definitely let you know if you need to round it. And if you're ever not sure, you're always welcome to shoot me a quick message. Yeah, as much as my wife would not like that. She's like, don't look at your email on the weekends. I'm gonna look at my email on the weekends because my students are taking a quiz. I gotta look at my email. So yeah, if you ever have a question like that, like I don't think so we can issue for this quiz, but for other quizzes it could be. All right, let's look at this last question. So suppose someone borrows $20,000. So if we borrow $20,000, that's our principal. And we wait 10 years, so 10 years pass without making a payment. It's not one of those cool, okay, what were those loans called? I don't remember. There's definitely different kinds of loans when you're a student. A lot of the federal loans are interest free. I think they're not Pell Grants. I don't know what they're called. Oh well. Anyway, this is not one of those. It's from a private loan lender, someone trying to make a buck. Just, their prerogative. And the interest is 6%. How much are we going to owe after these 10 years of not making payments? Well, this is again just a throw everything into the formula kind of problem. Right, the amount of money is P times 1 plus R T. Our principal is 20,000. Our interest rate is 0.06, and the time is 10. So then you just have to jam it all into a formula, use a calculator. So the only thing I would say is like, yeah, for these problems, you should definitely use a calculator. If you were not permitted a calculator, this would be a perfectly fine answer. That's all you can do. With a calculator, you end up getting that this is approximately $35,816.95. So right, that the interest definitely adds up. All right, that's all I have to say for